This is lesson 8.07, which is solving quadratics using the quadratic formula. And so the last couple of days we've been solving quadratics using the zero product property. We've also used, property. We've also used completing the square. And today we're going to use the quadratic formula. So similar to using the zero product property, when you use the quadratic formula, you must set the quadratic equal to 0. So the quadratic has to be equal to 0. And so the formula is used to solve for x. So when you have something like this, ax squared plus bx plus c, please remember this is called the standard form of a quadratic, and it's set equal to 0. If we're asked to solve for x, we're going to use this formula here. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, this formula, you do need to memorize it. And then this part right here, the part underneath the square root, this is referred to as the discriminant. Just the b squared minus 4ac is called the discriminant. And we're going to talk a lot more about that later. However, I just want you to know that because I'm going to refer to simplifying the discriminant in just a moment. So let's go ahead and do an example. I'll leave that at the top so you can see it. We're going to solve for x using the quadratic equation. First, we have to look to see is it set equal to 0, and it's not, so we'll go ahead and add 2 to both sides, leaving us with 3x squared minus 2x minus 5 equals 0. So to use the quadratic formula, we need to know what a, b, and c are, so I'll go ahead and list them here. A is 3. B is the coefficient of x, which is negative 2. C is the constant, which is negative 5. Now that I have that, I'm going to substitute these numbers into the quadratic equation, quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've just substituted numbers in. Now I need to simplify. X equals negative times a negative is a positive. And then there's a lot of stuff underneath that square root. So I'm going to come to the side over here and I'm going to simplify the discriminant. This is some scratch work. Start by negative 2 squared is a positive 4 minus 4. 3 times negative 5 is a negative 15. 4 minus negative 4 times a negative 15 will be a positive 60. So that equals 64. Substitute that back in. Again, this was the discriminant all over 2a. So, continuing to simplify, this is 2 plus or minus the square root of 64 is 8 divided by 6. Now that there's no square roots, there's no multiplication, I split it up into the two equations. X equals 2 plus 8 divided by 6, and x equals 2 minus 8 divided by 6. Simplify. 2 plus 8 is 10. 2 minus 8 is a negative 6. 10 over 6, divide both by 2, you get 5 over 3. Negative 6 divided by a positive 6 is a negative 1. And so x equals negative 1 and 5 over 3. For example number 2, we're going to do the same thing, except just know now that this one's a little bit more complicated. So first off, we have to set it equal to 0. So we'll go ahead and subtract 7 on both sides so that it equals 0. We're left with 3x squared minus 4x minus 5. Since I need a, b, and c, I'm going to go ahead and define what those are. A is the coefficient of x squared, so that's 3. B is the coefficient of x, which is negative 4. C is the constant, which is negative 5. So, plug it into the quadratic formula. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Start to simplify it. Negative times negative is a positive. That stuff is pretty complicated, so I'm going to come to the side and do some scratch work. Negative 4 squared minus 4 times 3 times negative 5. Negative 4 squared is a positive 16. 3 times negative 5 is negative 15. Then 16, negative times a negative is a positive. 4 times 15 is 60, which is 76. Divided by 6. Now, the square root of 76, this is not a perfect square. So what we need to do is we need to reduce this. So I'm going to come to the side. Square root of 76 is equal to 2 times 38. 38 is 2 times 19. And remember, this is really 4 times 19. So the square root of 4 is 2. And there's still a square root 19. Every time there are two of the same number, you remove one of them. So I'm going to replace square root 76 with 2 square root 19. So now we actually need to simplify this. Okay, so let me make a little note over here. If I gave you the problem 4 plus 2x, we would not combine like terms because they're not like terms. This would be our answer, right? The same thing is true if I gave you 4 plus 2 times square root of 19. These are not like terms because they don't have the same label, but really it has to do with the fact that this is 2 times a number. This is 2 times a number. And so we can't add things until we've already multiplied them together. So this is also just our answer. With that being said, we can't add these two things. Okay? The second note I want to add is if I gave you something like 4 plus 2x, they're both divisible by 2, so I could factor that out. And rewrite this with this. The same is true if that was a square root of 19. Since both of these are divisible by 2, I'm going to go ahead and divide out of 2. I'm left with 2 plus square root 19. Why do I care about that? Well, if you see the 6 on the bottom, I need to be able to reduce this, and I can. I'm going to rewrite the numerator as 2 square root 19, or 2 times the quantity 2 plus or minus square root 19. Now that this is multiplication, I'll rewrite the denominator as 2 times 3. But since this is multiplication, 2 times that stuff, 2 times this, then I can reduce that, and this simplifies to 2 plus or minus the square root of 19 divided by 3. This is actually what x equals. As ugly as that answer might be, that is our answer.